Welcome everyone to the study guide review video for the 8th grade Unit 2 quiz. We're going to go over every question on the quiz on the study guide, and there'll be a similar question on the quiz for each question we go over here. Question 1, circle the pair of polygons in which the image appears to be the result of a dilation of the preimage. So between these four pairs, which of these could be a dilation? Okay, well, starting with 4, we have the preimage here is this nice little rectangle, and then the image is this like weird looking quadrilateral. Okay, those are not the same shape, so it cannot be a dilation because dilations create scaled copies, okay, in particular locations. So if it's not a scaled copy, the two shapes aren't scaled copies of each other, then it can't be a dilation. So not pair 4 because those aren't the same shape. If you look quickly at pair 3, you might think that those are the same shape, but this shape, the preimage here, appears to be a pentagon, 1, 2, 3, 4, 5 sides. And then this is a hexagon, 1, 2, 3, 4, 5, 6 sides. So again, those aren't the same shape. They're not scaled copies, so it can't be pair 3. In pair 2, we originally have a square, and that gets squished and turns into a rectangle that's not a square. So again, those aren't the same shape, not scaled copies, so not pair 2. But pair 1 is correct. Okay, we have a rectangle and another rectangle. They appear to have proportional side lengths, the same angle measures. They appear to be scaled copies of each other. So pair 1 is an example of a dilation. All right, question 2 says, which statement could be used to describe the dilation that takes triangle ABC to triangle A double prime, B double prime, and C double prime? Okay, so what's important to pay attention to here is ABC is the preimage. This is here. So that is like my original shape. And then my image is the smaller one with the double primes. So when we have our dilation, it's going from a bigger triangle to a smaller triangle. So the dilation makes it smaller. So we have to think about what's an example of a scale factor that makes my shape smaller. Okay, scale factors that make it smaller are going to be in between 0 and 1. Numbers like 0.2, 0.3, 1/2, 1/4, 3/4, 2/8, any sort of fraction in between 0 and 1, or a decimal in between 0 and 1. Okay, so based on that, what's the scale factor? It cannot be a scale factor of 2 because that would make the shape larger, so we can eliminate A and C. The correct scale factor is here is 1/2. We're going, this is 4, and then this is 2, so it's being like divided by 2 or multiplied by 1/2. And then we have to figure out what is the center of dilation. Is it going to be the point 0, 0 or point A? Okay, so if it was point A, then A and A double prime would be in the exact same location because the center doesn't change. It's where the dilation happens from. So since we can see that A and A double prime are in different spots, it can't be A. Can't be that. So it's going to have to be B, but we can also see that from using our ruler. The way to find the center of dilation is you connect the corresponding points with lines. So here is point B, here's B prime. I draw a line that connects them. Okay, here's A double prime. I draw a line that connects them. And then here's C and C double prime. And I draw a line that connects them. And those all intersect right here at the origin at 0, 0. So that has to be my center. Cool. All right. So those were my mild level questions. Moving on to the medium. Triangle ABC is dilated using D as the center of dilation with a scale factor of 2/5. Label the side and angle measures in triangle A prime, B prime, C prime. Okay, so again, we have that our pre-image is the bigger triangle here. This is my pre-image, this is my original, and it's larger than my image, which is smaller. So we're going to have a scale factor of less than 1, like we have here. 2/5 is a fraction, it's 0.4 as a decimal. So that is going to make my shape smaller. Okay, and we're supposed to label the angle measures and the side lengths in my pre-image, in my image here. Okay, so to do that, we use the fact that what our scale factor does is we multiply our scale factor by the original side lengths, and that's going to give us our image or our new side lengths. Okay, so writing that down, we can take the original or the image lengths, and then we're going to multiply by the scale factor, and that's going to give me my new, oh, whoops, that should be pre-image, my bad. Pre-image is the original, and that's going to be my image new lengths. Okay, so we originally have this is 6 centimeters. We're going to multiply by 2/5 or 0.4, and that will give me my new side length. This is going to be 2.4 centimeters. Okay, 2.4 centimeters. So this is A prime C prime, and it matches up with AC. So we fill in the blank there. Okay, then we can do the same thing. This 7.5 centimeters. We multiply by my scale factor of 2/5. Right, you have a calculator. I'm not going to show off the work here, but you have a calculator. You can also do it by hand, of course, and you're going to get 3 centimeters for my new, for A prime, B prime. And then lastly, we have 3 centimeters times the scale factor of 2/5, and that's going to be 1.2 centimeters. Okay, so those are my new side lengths. And now we need our new angle measures. So in order for our angle, this was 21 degrees. So then what is this going to be? Well, this is also going to be 21 degrees, because we have to remember that for scaled copies, or similar figures, they have the same angle measures, right? And then the side lengths are what's changing, what's being affected by the scale factor. So if we measured that angle, it's about how wide it is. It'd be 21 degrees open. Okay, this is 108 degrees, so that means this is also 108 degrees. And this is 51 degrees, so this is also 51 degrees. Okay, the angles stay the same. There you go. You could add those up. 21 plus 108 plus 51 is going to equal 180 degrees, which is right because we know in any triangle the sum of the angle measures is 180 degrees. So you multiply the side lengths by the scale factor, and the angle measures stay the same whenever we have similar figures dilated. Cool. All right, moving on here to 4. Draw the dilation of ABCD using center C and a scale factor of 2. Label the vertices of the dilation A prime, B prime, C prime, and D prime. Sorry about those typos. All right, so here we have it. C is my center. C is my center, okay? So when it's going to get bigger in this case, we have a scale factor of 2. It's going to get bigger from that point C. So we can say, okay, C is my starting point. How do I get from C to point B? Okay, to get from C to point B currently, I go left 1, 2, 3, 4, 5, 6 units and down 2 units. Left 6, down 2. And then we know we have a scale factor of 2. So now I want to figure out, how do I get from C to my new B, B prime? And to do that, I'm going to take these original directions and I'm going to multiply by my scale factor of 2. Okay, so I'm going to take this, I'm going to multiply by 2, multiply by 2. Left 6 is going to turn into left 12, and down 2 is going to turn into down 4. So from point C, I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then down 1, 2, 3, 4. And that is my new B, B prime. And I'm going to label that point. Okay, the other thing you can do, should that be one higher? Should be one higher. The other thing you can do is, right, it's like you're going left 6 down 2, so you can do that again, left 6 down 2. Okay, but you might want to erase it after you do that. It gets a little messy. Okay, now we do the same thing. We'll do it a little faster to get from C to D. Went originally to get from C to D, we're going left 2 down 6. So we're going to multiply that by 2. Instead, we're going to go left 1, 2, 3, 4, and then down 12. Okay, so D should be at that point 9, 2. And the exact same thing, how do we get from C to A? To get from C to A, we're going left 5, and then down 5. So we're going to multiply left 5 down 5 times 2, and that's going to turn into left 10 down 10. There we have it, and then we're going to connect our new points. And we're going to connect that to where C prime would be. So C and C prime are going to be in the same spot because my center is C. We can have a center of dilation that's not on my shape, and then we wouldn't connect to the center of dilation, but here my center of dilation is my last vertex. It doesn't change because it's my center, and we get this. It should look like the same shape, but the side lengths are twice as long, and all the vertices are twice as far away from their original distance from C. Cool, beautiful. Question 5, describe the dilation that proves triangles ABC and A prime, B prime, C prime are similar. Be sure to include all necessary details. So if we want to prove two shapes are similar, we provide the sequence of transformations that will map one to the other. In this case, they already tell us what that is. That's going to be a dilation. Okay, because we need to change the size. ABC is my original. When we describe a dilation, we need the detail of what the scale factor is and what the center of dilation is. Okay, so for the center, we can again use the ruler method, or I mean, you might be able to see it without using a ruler, but we're going to connect A and A prime, draw a line, we're going to connect C and C prime, and draw a line, and we're going to connect B and B prime with the line, and those should all intersect right here at point P, which is why it's labeled for you nicely. So P is going to be my center of dilation. And then once we know that, to get the scale factor, we want to just sort of look at these original distances. So like from P to C, I'm going right 3. And then from P to C prime, I'm going right 6 units. Okay, so if we're going from right 3 units to right 6 units, the scale factor is 2. getting twice as long, just doubling the original distance. So my scale factor is 2, and my center is point P. Okay, so we have to provide both of those details. You would not get credit for this question. I mean, definitely not if you just wrote dilation, and definitely not full credit if you just wrote either center P or scale factor of 2. Awesome. All right, and then the last one is the trickiest. Describe a sequence of transformations that proves polygon A and polygon B are similar. Include all necessary details. So again, to prove that two shapes are similar, we have to prove that there is a sequence of translations, reflections, rotations, and dilations that will take one to the other. Okay, so there are multiple ways to do this. I'll show you the way that I think I would do it. I think is the easiest. And then I'm going to just make clear, even if you don't do it my exact same way, you need the level of detail that I have. Okay, so how I would do this, it doesn't matter which of these we consider our pre-image. So I'm going to consider like polygon B my original. So I'm going to start with polygon B. Okay, and to get it to, I'm going to try to map it so that it matches exactly on with A. So looking at this, I can see it needs to be spun, it needs to be rotated. You can use tracing paper, so you're welcome to use that on the quiz. But we have the shape, and it needs to be spun. It needs to be rotated so that it's facing the same direction. Okay, this would be better with tracing paper, but it would be like that is how I'm going to spin it. Rotate it. Okay. And what I just did, just redraw it, is I made this point my center of rotation. I spun it so we got here. So I spun it 90 degrees. That's a quarter turn, 90 degrees, counterclockwise. Okay, so that's not the way the clock spins. It's the other direction. So this is 90 degrees counterclockwise around this point. And this point right here is 4, 6. Okay, so I have to give all that detail. Rotate it, polygon B, 90 degrees counterclockwise around 4, 6. Okay, that's my center of rotation. Then what I would probably do from there, you can do this directly with the dilation, but what I would do is I would then try to translate it so that one of the vertices like matched up. So like I have this point right here, my bottom left-hand corner. I want to get that there, right? Because if it's then there, I have a clear center of dilation and I can dilate from there. So I'm just trying to slide it. Okay, so now I'm going to translate down 2 units and right 2 units. Okay, like I did before, it's going to be really helpful to me if I now draw it again. Okay, so again, you can use tracing paper for this. All of this part tracing paper would be helpful for. I'm going to get it here. And then the last step is the dilation. That's where tracing paper becomes less helpful. Finally, we're going to dilate it because we need to get it to be the same size. Okay, if I dilate this point, 6, 1, that is going to be my center of dilation because that point is already where I want it to be. So I keep that there. So dilate with center 6, 1. Okay, and a scale factor of, okay, well, let's see, how many times bigger do these side lengths need to get? So this is 2 units right now, and that needs to match up with this, which is 1, 2, 3, 4, 5, 6 units. So I need to get from 2 to 3, or sorry, from 2 to 6. 2 times 3 is 6. So my scale factor has to be 3. I'm getting 3 times as large. Okay, so that was long. The question is a little bit easier on the quiz, but it's the same sort of process where you're going to have to do either translation, reflection, or rotation, and you're going to need to dilate it. You have to give all the detail for rotations, degree, direction, and center, translations, distance, and direction. Reflection is the line of reflection, and a dilation is the center of dilation and the scale factor. All right, good job. Thanks for watching, everyone. Good luck.